function notation continues to be problematic for many people, especially when we try to use it for composite functions and showing the inverse property of inverse functions. So let's just talk a little bit more about function notation, the way I explain it, the way I approach it. F of x, let's let y equal f of x equal the function x minus 2 times x plus 3. And we know that to be a polynomial with zeros at 2 and negative 3. Okay, well, that's kind of worth keeping in mind, but it doesn't really matter for demonstration of function notation. We'll come back to that idea after we do a little bit. Okay, so let's see. Let's just verify this. F of 2 equals what? It equals 2 minus 2 times 2 plus 3, which is 0, times 5, which is 0. So indeed, 2 is a 0 of this function. And if we were graphing the function, the point 2, 0 would be on the graph. The point on the x-axis where x equals 2, the graph would go through that point. Okay, f of 3, f of negative 3 similarly equals negative 3 minus 2 times negative 3 plus 3, which equals negative 5 times 0, which equals 0. And again, we understand that that's going to give us a 0 on the graph of the function. F of a plus b. What's f of a plus b? Well, let's go back a minute and think about what we did when we said f of 2 was 2 minus 2 times 2 plus 3 equals 0. This is something everybody should understand, at least by the point, of course, at which I'm doing this, but let's be really careful. Okay, how do we know that f of 2 equals this? Well, f of x equals x minus 2 times x plus 3. If we replace x by 2, well, we've replaced x by 2, so we've got to replace this x by 2 and replace this x by 2, and here's what we get. To do f of negative 3, x is now negative 3, so x is negative 3, we substitute it, and we get these expressions. So now what we have is f of a plus b. Well, x has been replaced by a plus b. So every x in this expression has to be replaced by a plus b. Now that kind of begs the question why we would want to substitute a plus b, but that's okay. That's a legitimate question. I don't know why we would do that. I mean, yeah, actually I kind of do, but okay. So, you know, what's f? One of my favorite is f of aardvark. I really don't know why we would plug aardvark into this function, but if we did, we would have to follow the rule. X is replaced by aardvark. The only disadvantage of this, it takes a while to write it. It's aardvark minus 2 times aardvark plus 3. Now, of course, this expression or this expression could be simplified using the rules of algebra. And we'd use a distributive law, multiply these out, we'd use a distributive law here. Okay, what about f of x plus h? Now this often confuses people because we've got an x here, we've got an x here, but we're saying that x is replaced by x plus h. Well, if we do what we do for function notation, that means this x is going to be replaced by x plus h. And this x is going to be replaced by x plus h. Very simple. Okay. What we often see is people will write out f of x, which is this, and then put plus h on the end here. But that's not what the notation tells us to do. It says x has to be replaced by x plus h. Every x has to be replaced by x plus h. Okay, well, this becomes a very important expression. It's part of a difference quotient, which is very important. Extraordinarily important expression in mathematics. Starting with pre-calculus, you kind of need to understand that expression. Okay. Still, this should suffice to show exactly how literally we take this replacement when we use function notation. Okay, so what's f of g of x? If g of x equals, let's say, 2 to the x. Okay? Well, there are two ways to answer it. We still have this f of x function. We can do the substitution literally. Substitute g of x for every x. And we don't care what g of x is at this point. We can always do this. This will be g of x minus 2 multiplied by g of x plus 3. Very simple. And we can distribute that if we need to. We'd have a g squared, g of x and negative 6, but we don't need to do that. And if we do, we can. We don't need to do that right now. There are times when you want to do that. Okay, well, that's fine, but now we know that g of x equals 2 to the x. So we can replace g of x with 2 to the x. Now, another way of writing f of g of x, knowing that g of x is 2 to the x, we can replace g of x right here by 2 to the x. So we get f of 2 to the x. Now at this point, things tend to get a little confused because you want to think about this function, you want to think about that function. Just keep your wits about you one step at a time and do what the notation tells you. Okay? Notation, f of g of x tells you you're either going to do this or you're going to do this. And if you do this, you should end up the same thing you get when you do this. Well, let's see if you do. Okay? So, we can certainly replace g of x by 2 to the x. And then, of course, we have f of 2 to the x, so x has been replaced by 2 to the x. So every x is replaced by 2 to the x, and we get 2 to the x minus 2 from this, and 2 to the x plus 3 from this. And you got to be careful, there's going to be a temptation to write 2 to the x, and then the minus 2 might end up in the numerator here. Okay, you might write 2 to the x minus 2, or 2 to the x plus 3. No, it's 2 to the x minus 2. 2 is not part of a numerator here. It's not going to be a part of I say numerator. Sometimes I get the wrong words in my head. Again, 2 is not part of the exponent. You wouldn't write 2 to the x minus 2. Okay? 2 is just something that's subtracted from whatever this is. So be careful what you write. Don't write the negative 2 as part of your exponent. Don't write the 3 as part of your exponent. Okay. Okay, well, two different ways of doing this, and this is called a composite. And while we're at it, as you're often asked to do, what's g of f of x? Is it the same as f of g of x? Is this thing commutative? Well, let's see. G of f of x, well, g of x equals 2 to the x. If we replace x by f of x, we get g of f of x. So we'd better replace this x by f of x, and we get 2 to the f of x. Okay? But we know what f of x is. So this is 2 to the x minus 2 times x plus 3. But we could also have written this g of f of x equals g of x minus 2 times x plus 3, in which case this x is replaced by x minus 2 times x plus 3. So this x needs to be replaced by x minus 2 times x plus 3. We get 2 to the x minus 2 times x plus 3. So there we have it.